Hi guys, so today we're going to be learning about circular functions, and before we get started with our first example, let's take a look at some definition stuff in the book. Okay, so here now we're talking about unit circle again. Okay, so in a previous lesson I kind of talked to you about what's a great way to kind of memorize some of the parts of the unit circle. So now we're going to be using our unit circle. Okay. And then, so what we want to know is that the definition of sine and cosine, if the terminal side of an angle in standard position intersects the unit circle at a point, let's say x comma y. Okay, so what that means is it hits somewhere the unit circle. Then cosine theta is x and sine theta is y. Okay, and therefore the coordinates of P can also be written as P cosine theta, point P is cosine theta, comma, sine theta. Okay, and the way I can remember this is C in cosine comes before S in sine, and X comes before Y. Okay, so that's how I remember which one goes with which. Okay, okay. And then since there is exactly one point xy for any angle theta, the relations cosine theta equals x and sine theta equals y are also functions of theta. Because they are both defined using a unit circle, they are often called circular functions. Okay. So sine and cosine theta, we can use them as circular functions, right? Because they are on the unit circle. Okay. So given an angle theta in standard position, if P, which is given by these 2 points, lies on the terminal side and it's on the unit circle, so it's on the terminal ray, essentially, and it's on the unit circle, find sine theta and cosine theta, nice and easy. Okay. Since this is x, this will be cosine theta, and since this is y here, this will be sine theta, because it's on the unit circle. If not, we're going to have to use the thing that we've learned previously, right, where cosine theta is x over r and sine theta is y over r, right, which makes sense, right? If cosine theta is x over r, the reason why it's x is because on the unit circle, r equals 1. Okay, so that means cosine theta here is going to be 2 square root of 2 over 3, and then sine theta is negative 1/3. And there you go. Nice and simple. Okay. So why don't you try CYP1, and then once you're done, come check your answer. Okay, you should have gotten that cosine theta is square root of 6 over 5. Since it's on the unit circle, then x represents cosine theta, and then y sine theta is square root of 19 over 5. Okay, so now we're going to be using the unit circle and be talking about periodic functions. Okay. So here is the unit circle. It's on page 800. And again, in a previous lesson, I talked about what's a great way to memorize it. You are going to have to memorize it, and you're going to use it in the future. So it's good to memorize it now. Okay. Okay. Here, we're not going to talk a lot about the sine function or cosine function. That's part of chapter 14. Okay. But the sine function looks like this, and the cosine function looks like this. Okay, and it actually keeps going. Okay, and so because of this repetition, okay, we would say that the sine function and the cosine functions are periodic. Each of them have a period of 360 degrees or 2 pi. Right, so you can see here it is, and then basically it will repeat again, and then it will repeat again every 360 degrees or every 2 pi. Right, so for this is the cosine theta function. And then as you see, it will repeat again, and it will repeat again. So because of that repetition, it comes again in periods. That's why it is known as a periodic function. Okay, and then there's another definition for you right there. Okay, and because it's a periodic function, it means that when it's 90 degrees, that's the same value as it is when it's 450 degrees. Right, and you see that same thing here. Whatever it is at 90 degrees is the same as it is at 450 degrees. And because it's periodic at 360 degrees, even if something is beyond that, we can still use our unit circle to figure out what that is. Okay, so we're going to do cosine of 675 degrees. okay? And so cosine of 675 can be rewritten as cosine of 315 plus 360, okay? And then because of that, the 360, it repeats every 100, 360. This would be the same as cosine of 315, okay? Using my unit circle, cosine of 315, so that's the x value, right? Cosine is the x value at 315 is square root of 2 over 2. So then square root of 2 over 2. Because the idea is that we should have this, be able to memorize our unit circle, okay? So that way, even if we don't have a calculator, we can figure this out. Okay, the next one here is sine of negative 5 pi over 6. Okay, so here, since this is negative, I'm going to find its coterminal angle. So we learned how to find coterminal angles, and we can do that by adding 360 degrees, or in radian terms, that's 2 pi. Right? And as a result, negative 5 pi over 6 plus 2 pi, I can rewrite this as 12 pi over 6, right? Negative 5 pi over 6 plus 12 pi over 6, that's 7 pi over 6. And then using my unit circle, 7 pi over 6 is right here, and I wanted sine, so that's the y value, and so that is negative 1/2. Okay, and there you go. So can you do CYP 2A and 2B? Ideally, you would do it without your calculator and just using your unit circle. And then once you're done, come check your answer. Okay, for 2A, cosine of negative 3 pi over 4 should be negative square root of 2 over 2. And then sine of 420 degrees should be square root of 3 over 2. Okay, you should not be using your calculator at all. You should just need your unit circle. Okay, if you got that right, you can move on to our last example. If not, here is your explanation. Okay, so for this one, since it was a negative angle, I just found its coterminal angle, its positive coterminal angle, and I can do that by adding 2 pi, right? And this is because cosine is periodic, right? It repeats every 2 pi, okay? So then I just added 2 pi, which is 8 pi over 4. Negative 3 pi 4 plus 8 pi over 4 is 5 pi over 4. And then looking at my unit circle, 5 pi over 4 cosine is x, so that's here, negative square root of 2 over 2. Then for sine 420, I can break it down into sine 60 plus 360, right? It's periodic. It repeats every 360 degrees. So I can see it as sine 60. Okay? And then so sine is y value. So the y value at 60 degrees for my unit circle is square root of 3 over 2. So square root of 3 over 2. And there you go. Okay. So now moving on to our last example. Okay, so example 3 says, as you ride a Ferris wheel, the height that you are above the ground varies periodically as a function of time, right? Because it goes in a circle. Okay? Consider the height of the center of the wheel to be the starting point. A particular wheel has a diameter of 38 feet and travels at a rate of 4 revolutions per minute. Okay? A asks us to identify the period of this function. Okay? So if it repeats 4 times in 1 minute, right, that means it makes 1 rotation. If it's 4 rotations in 1 minute, right, 4 revolutions, that means 1 rotation or 1 revolution takes 1/4 of a minute or 15 seconds. So the period of this function is 1/4 of a minute or 15 seconds. Every 15 seconds, you'll be back right where you were before. Okay? And then here it says to make a graph in which the horizontal axis represents the time t in seconds. Okay? So here it is. Okay? And then the way that the book does it, I like how it drew a little picture of a Ferris wheel. Okay. Sorry, this is supposed to be a circle. This is where you're starting off. Okay, this is when you hit the highest, since the diameter is 38 feet. Right, so since here to here is 38 feet, that means the radius here is only 19. And then here, since this is starting point 0, this would technically be negative 19. Right, although you can't be negative 19 feet, but it's negative 19 because you're 19 feet below the starting point. Okay, so in the beginning of the Ferris wheel, okay, so it takes 15 seconds for a revolution to happen. So I'm going to do 15 here, do 30 here, 45, 60. Okay, this is my time in seconds, and this is my height in feet. Okay, so this is feet, this is seconds. Okay, in the beginning, you are here. Okay. And then halfway, you're back in the middle, and then at 15, you return. Okay, so you're going to be in a fourth of the time up here, right? Because it's going to spin. You're going to go up, and then you're going to come back down, and then you're going to go back all the way to the bottom here, and then you'll be back here. Right? So everything is kind of divided into fourths. So 1530 divided into fourths. So then you're going to go up, then back to the center, right? That's when you come back here, and then back here and here. Right? So you'll see it repeats every 15 seconds. All right. So I don't have to do my graph this elaborate, but then again, it goes up here, then here, and down here, and then I'm back to I did a whole revolution in 15 seconds. Okay. And same thing here. Which is why here we know that in 60 seconds or a minute, we've done 4 revolutions, right? 1, 2, 3, 4. And there you go. Okay. So why don't you try CYP3 on your own, and then once you're done, come check your answer. Okay, this is what you should have gotten. So your period should have been 1/5 of a minute, which is 12 seconds. And here's your graph. The highest is 22, the lowest is negative 22. And then I decided to do 5 periods here in this, right? Because that's 60 seconds, right? And it repeats every 12 seconds. Okay. If you got that right, you can get started on your homework. If not, here is your explanation. Okay. So if it makes 5 revolutions per minute, that means 1 revolution or 1 rotation is 1/5 of a minute. Okay, so a minute is 60 seconds, so 60 divided by 5, 12 seconds. Okay. So then that means, okay, here if I have my Ferris wheel, and we're doing the middle as our starting point, if the diameter is 44, okay, that means its radius is 22. Okay. So that means the highest it gets is 22 above the center, and 22 below the center is the lowest. Okay. And so here, as I'm going, it takes this time to go up, then I'm going to hit back to the regular, and then I'm going to go down, and then I'm going to go back. And it keeps repeating. And there you go. Okay. So that's it for today. Have a great rest of the day. Bye, guys.